Hi student, welcome to chemistry class with Emerald. In today's class, we are going to be looking at acid, bases, and salts as electrolytes. This class is brought to you by Egota Virtual Learning. In the class today, we are going to look at the definition of an electrolyte, the types of electrolytes, the difference between strong and weak electrolytes, what are non-electrolytes, the difference between electrolytes and non-electrolytes, the conductivity of acid and bases, and of course the enthalpy of neutralization and the electrolyte. At the end of the lesson, you must be able to define electrolytes and non-electrolytes. You must be able to state the different types of electrolyte and the difference between a strong and a weak electrolyte, the difference between an electrolyte and a non-electrolyte. Of course, explain conductivity of acid and bases and the enthalpy of neutralization. An electrolyte or electrolytes are substances that dissolve in water to produce ion, allowing them to conduct electricity. They are substances that dissolve in water to produce ions, allowing them to conduct electricity. Of course, in your knowledge of chemistry, we have three discrete particles of matter: the atoms, the molecules, and the ions. Ions are electrically charged and therefore they can conduct electricity. So any substance that can dissociate or dissolve in water to produce ion are known as electrolyte. Why? Because they can conduct electricity. Example of substances like these are acids, bases, or salts that dissolves into positively charged cations and negatively charged anions. Example of salt include NaCl and KCl. For instance, if NaCl dissociates in water, it produces Na plus and Cl minus. Na plus positively charged cations and Cl minus negatively charged anions. Other examples are acid, e.g. HCl. It dissociates to produce H plus and Cl minus. Another one is NaOH from the base that dissociate to give Na plus and OH minus. What are strong electrolytes? Now we can classify electrolytes as strong and weak based on their ability to dissociate in solution. Some of these ions will dissociate completely, while some of them will dissociate partially. A strong electrolyte, therefore, is a substance that can dissociate completely in solution. This complete dissociation enables it to conduct electricity efficiently. It's able to conduct electricity efficiently. Example of a strong electrolyte include a strong acid and a strong base. An example of a strong acid, examples of strong acid include HCl, H2SO4, and an example of strong base include NaOH and KOH respectively. There are key major characteristics of a strong electrolyte. Number one, it undergoes complete dissociation. That means, for instance, let's take an example of HCl. You are going to have H plus and Cl minus. No H plus is remaining about N. But you compare with a weak electrolyte that will still retain some part of H plus in the makeup. Okay, so it is important that we take note of this. Another one is high conductivity. A strong electrolyte usually conducts a strong electrolyte usually conducts in a high fashion. The conductivity is high. Number 3, there is high dense concentration of ions. The percentage of ions in the solutions are usually high. For a weak electrolyte are substances that dissociate partially into ions in water, resulting in lower concentration of ions in solution. This partial dissociation limits the ability of weak electrolytes to conduct electricity. That is, they are not going to be able to conduct efficiently when compared to the strong electrolytes. Example of weak electrolyte includes weak acid and bases, e.g., citric acid, ammonia, acetic acid, etc. Their characteristics are 1. Partial dissociation, low conductivity, and low ion concentration. Let's look at the differences between a strong and a weak electrolyte. In a strong electrolyte, we have complete dissociation in solution. For weak electrolyte, we have partial dissociation in solution. For strong electrolyte, we have high conductivity. For weak electrolyte, there is low conductivity. For strong electrolyte, there is high concentration of ion. In weak, we have a low concentration of ion. And then for strong electrolytes are basically strong acid and strong base. And of course, normal salt. While weak electrolytes are basically weak acid and weak base. Let's look at non-electrolytes. Non-electrolytes are substances that do not dissociate into ions in water and therefore do not conduct electricity. They typically consist of polar or non-polar molecules that do not ionize. Non-electrolytes consist of covalent bonds instead of ionic bonds that can aid formation of ions and of course conduction of electricity. Non-electrolytes will contain covalent bonds, and of course they will not be able to dissolve readily in water to form ions. Examples of non-electrolytes include alcohol, also known as ethanol or alkanols, non-polar molecules, and UI. Their major characteristics are they do not dissociate into ions. That means that they remain as molecules in solution and they do not conduct electricity. That means they do not allow the flow of electric current through them. Let's look at the difference between electrolytes and non-electrolytes. Electrolytes will dissociate into ions in solution. Non-electrolytes do not dissociate. For electrolyte, they conduct electricity due to the presence of ions or mobile ions present in them. Non-electrolytes do not conduct electricity because they do not dissociate in ions. Examples of electrolytes include strong acid and base. Examples of non-electrolytes include non-polar molecules and alcohol. Of course, in a typical electrolyte, you usually have majorly ionic bonds, and of course for non-electrolytes, usually covalent bond that exists in them. Okay, let's look at conductivity of acid and base. Acid and bases can be strong or weak electrolytes, and of course that will affect their conductivity. Strong acid and strong base, because they completely dissociate, can conduct electricity and are due to high concentration of ions. For weak acid or weak base, they partially dissociate into ions, therefore their conductance will be poor or fair due to the low concentration of ions. Therefore, Strong acid and strong bases are strong electrolyte and of course will conduct electricity well. Weak acid and weak base are weak electrolytes, therefore will conduct electricity poorly. The degree of dissociation affects the conductivity. That means the degree of dissociation into ions is directly proportional to the conductivity. Understanding the conductivity of acid and bases is crucial as it impacts their behavior in solution and their applications. Let's look at enthalpy of neutralization. The enthalpy of neutralization is the energy change when an acid and base react to form salt and water. This concept, of course, relates to acid and base as electrolytes in the following manner. Strong acid and strong base have high enthalpy of neutralization. That means that they have enthalpy of neutralization around minus 57.3 kilojoules per mole. Of course, the reaction is exothermic. The reaction is that means heat is liberated during that reaction. Because of this high enthalpy of neutralization that we have, of course, we have the H plus from the acid and OH minus from the base to form H2O. Only strong acid and strong base can give this enthalpy of neutralization. For complete, of course, strong acids also have strong acid and strong base have complete dissociation. Therefore, the energy release support their dissociation into ions and making them strong electrolytes. For weak acid and weak base, they have low enthalpy of neutralization and they have partial dissociation. Now, what is the impact of enthalpy of neutralization on acid and base in their function as electrolytes? Number one is energy release. The enthalpy of neutralization influences the degree of dissociation and consequently the strength of the electrolyte. Again, a stronger enthalpy of neutralization will result in high ion concentration, and of course it will enhance the electrolyte function. So let's look at some activity in this module. Identify each of the following substances in aqueous solution as strong, weak, or non-electrolyte, as a strong electrolyte, a non-electrolyte, or a weak electrolyte. By now, you should be able to identify which one is a strong electrolyte, which one is a non-electrolyte, and which one is a weak electrolyte. If you have done it very well, C12H22O11 is sucrose, and that's sugar. And sugar are known as non-electrolyte, like we have rightly proceeded. NH3 is a weak base, and of course, it's going to be a weak electrolyte. And NOH is a strong base, so it's going to be a strong electrolyte. Another activity too, the conductivity of an acid solution depends on the amount of ions present and their mobilities. Number two, mobilities of ions present. Number three, amount of ions present. Then the D option is temperature of solution. The answer is the amount of ion present and their mobilities. Amount is talking about the concentration of the ion. The higher the concentration, the greater the conductivity, and of course their mobility. So the answer is A. So this is end of the class for today. So far, we have been able to learn about what an electrolyte is, the types of electrolytes, that's strong and weak electrolytes, and their examples. We have been able to look at the difference between strong and weak electrolytes. We've also been able to look at a non-electrolyte and the difference between electrolytes and non-electrolytes. We have looked at the conductivity of acid and bases, and of course the enthalpy of neutralization and how it affects the function of acid and base as electrolytes. Continue to learn chemistry. See you in the next video, and bye bye.